Hey everyone, welcome to Git Fundamentals video series from ABC Start. In this series, I'll be going over some of the basic Git concepts and will discuss real-world scenarios covering how Git can be used effectively. We'll go over some basic commands followed by detailed practical demonstration. The goal here is simple, to conceptually understand Git in a nutshell. I won't spend a ton of time going over its background like when it was created, who was the author, and things like that. You can always look for those details online. We'll instead try to stay to the point and focus on practical stuff. In this video, I'll give a brief introduction of Git architecture, followed by a small use case to understand things better. So let's get started. Basically, Git is a distributed version control system. This means that your project and its entire version history is reflected on every developer's computer. The project is maintained among peers and multiple copies of it might exist among them. Since whole project is on one's workstation, it allows developers to make contributions offline to the project and then once they are finished, can easily push stuff to a remote repository hosted on another peer computer or server, which can be called as a single source of truth or a one common repository. Example being your company's repository hosted on a remote server containing stable version of your project. There are certain components that Git comprise of, and we'll discuss them briefly one by one. Repositories. A repository is usually referred to as one single project. A repository can contain folders, files, images, videos, etc. You can think of it as one root directory inside which every file or folder is tracked. All the version information is also stored inside it. Branches. Branching is a core feature that Git offers. It allows us to create independent lines, quote-unquote, branches of development. Let's suppose you have a master branch with most recent state of a project denoted by commit A. Then one developer comes in with a task to implement a new feature. He'll go ahead and checks out most recent version of the project at commit A and create development branch. He then adds 3 commits indicated by blue circles with new functionality in development branch. Later, he merges his changes to master branch as commit B. Another developer then comes in with a task to implement another feature. He'll go ahead and create a new branch called staging, add 2 commits and merge his changes back to master branch as commit C. Note that in order to merge to master, he must bring in all changes up to commit B to his branch, process called rebase, which we'll discuss in upcoming videos, and then merge his stuff as commit C back to master branch. You might have noticed how two developers worked separately on individual features on top of initial version of project and nicely merged their changes. So up to commit C, master branch have changes from both development and staging branches, while their individual changes are safe in their own respective branches. Then let's say someone wanted to add urgent changes to master. He'll go ahead, checks out current master at commit C, makes his changes and then add another commit D without creating another feature branch. An important thing to remember here is that the most recent commit of any branch is called as the head of the branch. Moving on to simple representation of Git architecture. So at the highest level, you can have n number of repositories or projects, whatever you want to call them. And inside each repository, you can have n number of branches depending upon how many independent lines of project development you want to carry out. Inside each branch, you can have n number of commits depending upon how many checkpoints or versions you want to record for each branch of development. For more clarity, let's execute a small use case. Let's suppose your company created a repository on its server that contains initial version of the project with some branches, let's say dev and production. Later, One developer who is situated on another remote location is assigned to add a new feature, let's say feature X, to the project. What he'll do next is he'll clone the repository into his machine, a replica known as local repository, which will contain the same number of branches as the remote repository. What he'll do next is that he'll create a new local branch, let's say dev underscore A, to implement his feature in his local repository. And then once he's done, he'll merge that in the local version of dev branch cloned from the remote repository. At this point, dev branch in his local repository is ahead of dev branch in the remote repository by one commit. Then he'll go ahead and push his updated dev branch to remote repository so that dev branch there is updated as well with his new changes. Then at a later point in time, another developer is hired and tasked with implementation of another feature, let's say feature Y. He'll clone the remote repository the same way both the development and production branches from repository will be cloned into his local repository. Note at this point, dev branch that came as a result of the clone will contain changes done by the first developer, as he already merged his changes to the remote version of the dev branch. The second developer will then do the same, create a new feature branch, let's say dev underscore B, in his local repository, implement his changes, and then merge his branch to the dev branch in his local repository. Now let's suppose their team lead jumps in and gets to know that the development has been completed. In order to make the code changes live in production, he'll go ahead and merge the dev branch into production in the remote repository. That way, all the changes that the both developers worked on gets merged to the production branch, and then later he can deploy the app using the latest code from the production branch. Here we saw how a complete development iteration is performed by two developers working on the same project and how they merged their stuff leveraging branching feature of Git. In the upcoming video, we'll see how practically this can be achieved using Git commands and how you can initialize a repository, create branches, add commits, merge changes to a remote repository or a local repository, and a lot of other cool stuff. Hope you liked this brief intro. If you did, don't forget to subscribe to my channel and hit bell icon if you want to stay informed about my upcoming videos. See you all in the next video. Till then, goodbye.